Hi guys. Please, I want to encourage you guys to subscribe to my channel, MT Tutorial, where we look at questions and physics questions. I will be explaining concept in physics in a way that you easily get it. So please, I'm asking you for your support. You can support my channel by subscribing, like my video, watch them, and I'll be so grateful. Thank you very much. 2012 Waec physics practical past question. Based on what Waec has us to provide, this particular question covered a lot of things. If we are to consider the apparatus we are asked to provide. So here you can see this diagram. One thing about physics practical question is all you need to do is read instructions and follow through with the instructions. If you are able to do that, you are good to go. So we have two illustrations here. So we have the beaker, the return stand, and the spring balance. So inside the beaker here, the first beaker here is water, while the other beaker here has liquid hell. Waec asks us to provide kerosene. So we believe that liquid hell is the kerosene. So we are just going to set our apparatus up just like it is in this illustration. So please stay with me, and definitely need a return stand. This is my return stand here. This is my beaker with liquid hell. Kerosene is inside this beaker. Then the second beaker has water inside of it. This is my spring balance and the masses. Now I was asked to provide the 50-gram mass, 100-gram, 150, 200, and 250. So all of these four masses will do that for me. 100, 100, 50, 50 will do that for me. Now for your spring balance, the first thing you take note of is to be sure that there is no zero error. If this pointer is not starting from 0, you have to adjust this control here. You adjust it until the pointer is exactly on 0 before you use your beaker and your spring balance. So now I've adjusted it. I pulled it a little bit because the pointer is far above the 0 point. So I adjusted it, and now it is on the 0 point. So this way my spring balance is ready for the experiment. So we can use this one. So now you fix your spring balance on this side of your return stand. So this place is holding my return stand for me. So I'll just tighten it up so that it will be firm. I don't want it shaking. You use this side to either lift this part up or drag it down a little bit. So depending on what you have, when you are about inserting your mass inside the liquid, you should insert the mass massively. That is, it should be massively inserted inside the liquid. You don't want some part of your mass outside. So if you have that will not be following the instruction. So you should follow the instruction. The mass is to be inserted massively inside the liquid. So after that, another thing you should take note of is your scale. On my spring balance here, I have the Newton scale and the gram scale. You can see the gram scale here, 0, 50, 100, 150. So for this experiment, we are asked to look for W1. W1 is the weight of the mass in air. So I'm concerned with the weight. The unit of weight is Newton. So I'll be using this scale for the experiment. So let's quickly talk about how to find the smaller divisions. This is how my spring balance scale look like. I have 0, then in between 0 and 0.5, I have 1, 2, 3, 4 smaller divisions. Do you understand? So if I want to get the value of each of these smaller divisions, I will just say this 0.5 here divided by 1, 2, 3, 4, 5. So I'll point my calculator now to get the answer. 0.5 divided by 5. Don't forget I started from here. 1, you're not going to count 0. 1, 2, 3, 4, 5. So this is 0.5, then 0.5 divided by 5. And 0.5 divided by 5 is 0.1. So that means this one is 0, then this is 0.1. So if the difference between each of these divisions is 0.1, then this one will be what? 0.2, then this 0.3, then this 0.4, then you have 0.5. So here now, the difference is what? Is 0.1. How did we get 0.1? I said what? 0.5 divided by 1, 2, 3, 4, 5, divided by 5. So that's 0.1. So now, for this is 0.5. So if this is 0.5, this one will be what? 0.5 plus what? 0.1. That's what? 0.6. So if I want to get this, 0.6 plus 0.1, that's 0.7. Then 0.8, then 0.9, like that. So in some cases, if you want to get your answers, you can just count the numbers of lines you have. For example, this is 5. If I want to get the readings for this place, for example. So this is 5. From this place to this place is 5. 1, 2, 3, 4, 5, 8. So what I will do is 0.1 times 8. 0.1 times 8 is what? 0.8. So that's how you get it. If I'm looking for this side, for example, from here, I know from this place to this place is 10 already. Then plus this one, that's 11. So I'll just say 0.1 times 11. That will be what? 1.1. So this side is 1.1. This will be 1.2, 1.3, 1.4, like that. Okay, so now that we are aware of how to read, how to take our measurement on the spring balance, the next thing to take note of is that you should avoid parallax error. Now, for zero error, you should avoid zero error also. So I corrected that by using this this knob here. I used it to adjust the pointer. So for parallax error, I want to avoid parallax error means that whenever I'm taking my reading, I should make sure I bend up to the level where my pointer is, and it should be my view should just be what? Directly towards that pointer. You are not to look from the back, from behind, neither are you to look from the side. So if you want to avoid parallax error, you are looking directly on that point. You lower your head to the level of the pointer, and you're looking directly at that point on your pointer. Next thing to do, the question says that we should determine the weight of object of mass m is equals to 50 grams. Now I'm using this angle. I will use this angle throughout the experiment. You are not to change the angle you are using, so you not have errors in your reading. So for this, I'm using this angle. Then I'm to measure. This is a 50 gram mass. The 50 gram mass. So I'm to measure the weight of this mass. So just by hanging this on the spring balance, I am measuring the weight in hair, because the medium here is hair medium. I'm not inserting this mass in any liquid. I'm not inserting it in the water. I'm not inserting it in the kerosene. I'm just hanging it there in the hair. So that way, whatever measurement I'm able to get here is the weight of the object in hair. And that is our WL for 50 gram mass. So we want to take the reading for that. So looking at what I have here, I have 0.6 Newton. So then you come here to record that. So W1 for 50 gram mass, that's number 1, is 0.6. So you want to record your readings in 2 decimal places. That's with water before I move to my liquid, because my WT is the weight of these same objects. The weight of this same object in water, that's my W2. So what I'll do now is to insert this object in water. Now I want this object to be what? To be immersed in water. My object is inside that water. It's not hanging there. I'm not doing it in such a way that part of it is outside and some is inside. Except you are instructed to do that. But for this experiment, I'm asked to insert every part of the mass in water. So that is what I have done. So it is inside the water. It is immersed inside the water. So now we now take the reading. Now that it's inside the water, you take your reading. So what is your reading now that is inside the water? So now that it's inside the water, I can see 0.5. So the weight of this same mass in water is now 0.5. So I'm recording 0.50. So that's 0.5 Newton in water. 2 decimal place for your measured value. Don't forget that's some for your table in Waec. So I'm done with weight in water. Now I want to do weight in kerosene. Now before you do that, water in the mass. You clean up, even my anger. I have to get a dry cloth material or towel material, whatever. It can be a tissue paper. You wipe off all the water in the mass, just to avoid errors, because if you still have water there, it can affect your reading when you start it inside the liquid air, which is kerosene. So our W3, according to the question, is the weight of the object in liquid air. So I will be starting this object in liquid air now. Then I will now take the readings. Now that it is started in liquid air, I'll take my readings. So now what I can see here is 0.55 because the pointer is in between 0.5 and 0.6. So this is 0.55. At this point, you move the 50-gram mass. We are done with the 50-gram mass. Now we move to the next mass. The next mass is 100-gram mass. So I wiped off the kerosene on my anger. So now I'm done with the 50-gram mass. So now we are moving to the 100-gram mass. So the first thing is to find W1. That is the weight of the 100-gram mass in air. So what I will do is just to hang the 100-gram mass in air. I'm not inserting it in any liquid yet, so I'll just hang it in air. So that way I will be able to take the measurement, the weight of the 100-gram mass in air. So the weight of the 100-gram mass in air, based on what I'm seeing here, is 1.1. 1.1. So I'll take my reading as 1.10, 2 decimal places. So the next thing to do is to find the weight of this 100-gram mass in water. That's our W2. The weight of the 100-gram mass in water. Don't forget to insert it. So we take the reading of the weight of the 100-gram mass in water. So the pointer is between the 0.9 and 1.0. So that is 0.95. So our reading, the weight of the 100-gram mass in water is 0.95. So the next thing to do is I want to measure the weight of my 100-gram mass in this liquid air. That is my kerosene. So I will hang it. Don't forget you have to immerse it in the liquid. So another thing you should not forget is that the mass should not in any way touch the sides of the beaker. It should just be at the center there. It should not touch the side. It should not touch the bottom. So at this point, you can now take your reading. For our reading is, the pointer is directly on 1.0. So our reading on the kerosene, for the mass of the object in liquid air is 1.00. Remove the mass, 100-gram mass. I have to clean it. Wipe off the kerosene on my 100-gram mass. I'm done with the 100-gram mass. I've recorded my W1, weight of the 100-gram mass in air, W2, weight of the 100-gram mass in water, W3. We have to look for W1, that is weight of the 250-gram mass in air. Now, for my 250-gram mass, I have 3 masses here, 100, 100, and 50. So that makes 250. So I'm going to hang it in air here, and I'll take my readings. 2.55. Weight in air is 2.55. Get W2. W2 is weight of my object in water. That is weight of these masses when inserted in water. Another thing is that the water in your beaker, including the liquid itself, it should not get filled to the brim. Now when I inserted the water, the level, the volume of the water increased. So if it's too much, I'll have water just pouring away on the table here, and that will not be too good. So you should fill in the water or the liquid not to the brim. So just before the brim, that will be okay. So here we have, this is 2.2. 2.20. I'm done wiping off the liquid on my mass. That's the water on my mass. So you want to wipe it up very well. You wipe it up. Even the anger, the water on the anger should be wiped up, because now we are looking for W3. That's the weight of these same masses, this same 250 gram mass. I want to get the weight in liquid L. That is kerosene. Its weight in kerosene is what I want to get now. So I'll be inserting it inside the beaker. It should be touch your beaker. So this is 2.3. So now we have to fill in our tables. Here, according to the question here, we have to find U is equals to W1 minus W2. The U there is obtruse. Now, if it is weight in W1 is weight in air minus weight in water. So that is obtruse of the object in water. So that is obtruse of the object in water, or obtruse. So this is W1, this is W2. So you just say 0.6 W1 minus 0.5. So what is 0.6 minus 0.5? That is 0.10. So because it's a calculated value, I'm going to make it 3 decimal places. So for this also, I have 1.1 minus 0.95. So that is 0.15. Then I'll add 0 so that my values will be in 3 decimal places. So like I'm using 3 decimal places, everything here should be in 3 decimal places. Here I'm using 2 decimal places, everything should be in 2 decimal places. So for this one, 1.55 minus 1.30 is 0.25. So I'll be recording 0.250. Then here, 2.10 minus 1.80, 0.3. So I'll be recording 0.300, 3 decimal places. And the last one here is obtruse in water. Then I'll move to V. We have to record V also. V is equals to W1 minus W2. So that is weight of the object in air minus weight of the object in liquid L. That's the kerosene. So that's 0.6 minus 0.55. And that is 0.050. 3 decimal places. And the next one is 1.1 minus 1. 0.1, then 00, so that it will be in 3 decimal places. 1.55 minus 1.40. 40, that is 1.1. I'm adding the zeros to have 3 decimal places. So the next one is 2.10 minus 1.85. 2.10 minus 1.25. So I'll record 0.250. W1 minus W3, which is the last part. That's 2.55 minus 2.25, and that is 0.3. So I'm going to record 0.300. So this way I am done taking my readings. So considering our values here, there are some things you should know that can even guide you as you do your experiments. Compare water and the liquid air. That is, we know that our liquid air is kerosene. So if we are to compare the two, water is heavier than kerosene. So if you mix water and kerosene together, this is a mixture of water and kerosene. You notice a layer here. There's a difference here. The water is at the bottom while the kerosene is at the top. So that tells you that water is heavier than what? Than kerosene. So what happens, because water is more denser, the weight of the same object in water should be lesser than the weight of the same object in kerosene. So you can see that here we have 0.5, while in kerosene we have 0.55. The same thing here. In water, 0.95. This is a 100 gram mass. In water, the weight of that 100 gram mass in water is 0.95, while the weight of the 100 gram mass in kerosene is 1.0. So it should continue like that. Then the U here is the obtruse of the object in water. So that is what? Weight of the object in air minus weight of the object in water. That's 0.10. So this is talking about the buoyancy of the object, and because you have different weight in the two mediums, so you are going to have reduction in weight for this one when the mass is inserted inside water. We have reduction in weight. So the difference in the two is the obtruse. So, and for V here, that's W1 minus W3. That is weight of the object in air minus weight of the object in liquid. W1 minus W3. So that is, the liquid is kerosene. So what I'm looking for here with W1 minus W3 is the obtruse of the object in liquid L. That is in kerosene. The object of the object in liquid L in kerosene. So that is the loss in weight of the object when inserted in kerosene. So for the 50 gram mass, you have 0.050. So like that. So that will be the end of today's practical class. So you can just go ahead, because the question is to plot a graph of V on the vertical axis and June 20